Hi, this is Andrea Hendricks. The topic of this video lesson is the law of sines. You will recall in our study of trig thus far we've only worked with right triangles. And we know that right triangles are triangles in which one of the angles is a right angle or 90 degrees. Now we're going to turn our attention to work with oblique triangles. And oblique triangles are triangles that have no right angles. So they can actually be one of two types. We could have an acute triangle where all of the angle measures are less than 90 degrees, or we can have an obtuse triangle where one of the angles is larger than 90 degrees. Our goal now is going to be able to solve an oblique triangle, which means that we want to find the measures of all the angles and the lengths of each of the sides. Well, to be able to do that, we have to know some of the values from the angles or sides. In fact, we have to know this. We have to know at least one side and two other parts. Those two other parts could be two angles, or two other sides, or an angle and a side. Using the law of sines, which I'll show you in just a minute, we can actually solve a triangle when we know this: one side and two angles, and two sides and one angle. There's going to be two other cases that we're going to look at when we learn the law of cosines. But in this section, we're going to talk about learning what the law of sines is, using the law of sines to solve the triangles in those two cases that I just mentioned, finding the area of an oblique triangle, and then lastly, using the law of sines to solve real-life problems. So let's proceed and talk about what we can do for the law of sines and what that actually is. So the law of sines is pertaining to an oblique triangle when the vertices of the triangle are labeled A, B, and C, and the side opposite the respective angle is denoted with the lowercase letter of that angle. So the side opposite angle A is represented by lowercase a, the side opposite angle B is represented by lowercase b, and likewise the side opposite angle C is represented by lowercase c. Nothing new, I think we've already done that before. Now this is an oblique triangle, and I have a height drawn down in this triangle, the height of the triangle represented by the letter H, and I've done that because now I have some right angles, and I can use the sine functions to denote the sine of angle A, B, and C. Now, I won't be able to do the sine of angle C, but you could look in your book to see that it's basically the same thing. So for the purpose of this, let me just talk about angles A and B. So if I wanted to find the sine of angle A, I'm going to have what? Opposite over hypotenuse. So don't let the H there confuse you. That's the height of the triangle here. If I wanted to find the sine of angle B, well, the sine of angle B would be opposite over hypotenuse, which would be H over A. I would have to construct another height to be able to find what angle C's sine is, so don't worry about that. But we can represent H now as really B times sine A. And likewise, from the other equation, we can represent it as H times sine B. So what we have is that really B times sine A is equivalent to A times sine B. Well, if I divide by B and A, if I divide each side by B and A, I get this sine A over A is equal to sine B over B. Now I could have also divided by sine A or sine B, and we know that this is legitimate because we're never dividing by 0. It wouldn't make sense to have a side of length 0 here. I get this equivalency that sine A over A is equal to sine B over B, and it would be the same thing for sine C over C, and that is exactly what the law of sines is. It says the sine A over A is equal to the sine B over B is equal to the sine of C over C. Or I could divide by the sines and have the lengths in the numerator. Depends on which one I need to find. If I need to find the angle, I can put the angle in the numerator. If I need to find the side, I can put the side in the numerator. So the idea is that we're going to use the law of sines to construct a proportion where these two ratios are equal. So we're going to set something like sine A over A equal to sine B over B, or sine A over A is equal to sine C over C. So let me stop this video, and then in the next video I'll show you how to actually apply the law of sines.